You're standing at the mouth of a narrow tunnel beneath a simple wooden farmhouse in Holmes County, Ohio. There are no wires running into it, no compressor humming in the background, no thermostat mounted on a wall, and yet, in the middle of August, when the outside air presses down heavy and hot, the air flowing out of that tunnel feels cold enough to make you pause. Not cool cold, around 55 degrees Fahrenheit, steady, quiet, constant, and the deeper you look into it, the stranger it becomes, because there is no machine creating this effect. There is nothing modern about it at all. What you are looking at is not new technology. It is something older than the house itself. Something that has been quietly working beneath people's feet for thousands of years without asking for permission, without needing maintenance contracts, without ever showing up on a monthly bill. And the moment you understand what is actually happening here, a question starts forming in the back of your mind. If something this simple can produce air this cold, using almost no energy, why isn't it everywhere? Why isn't every home built to take advantage of it? Why does the average household spend hundreds of dollars every summer just to stay comfortable, while this system sits silently underground, doing the same job with a fraction of the effort? That question is not just about cooling. It is about how we build, how we think, and how easily practical knowledge can fade when it no longer fits the systems around it. Because what you are seeing is not a trick. It is a direct application of a physical reality that exists under every home. At about 6 feet below the surface, the temperature of the ground stops following the weather above. It stabilizes. Summer heat, winter cold, sudden changes in temperature, none of it penetrates quickly enough to disrupt that layer. The soil becomes a thermal anchor, holding a steady temperature all year long. In much of the United States, that temperature sits somewhere between 50 and 60 degrees Fahrenheit. In Holmes County, it stays right around 54 to 55 degrees. Day after day, season after season. This has been measured and documented by institutions like Oak Ridge National Laboratory. And while the exact number shifts slightly depending on geography, the pattern remains consistent. A few feet down, the ground stops reacting to the chaos above. It becomes stable. And stability, when it comes to temperature, is one of the most powerful tools you can have. Because once you have access to a constant temperature, you no longer need to fight the environment. You can work with it. Modern air conditioning systems rely on mechanical force. They compress refrigerants, move heat from one place to another, and depend on continuous electricity to maintain that process. They are effective, but they are also energy-intensive and dependent on infrastructure. The system beneath that farmhouse does something fundamentally different. It does not fight heat. It redirects airflow through a space where heat naturally equalizes. An earth tube system is, at its core, a buried pipe. Air enters one end, travels underground, and exits into the home. As it moves, it exchanges heat with the surrounding soil. Hot air gives up heat. Cold air gains it. Over distance, the air temperature moves toward the stable temperature of the earth. By the time it reaches the house, it is no longer extreme. It has been moderated, quietly and continuously, by the ground itself. What makes this effective is not complexity, but mass. Soil is dense. It takes a significant amount of energy to change its temperature. When the sun heats the surface during summer, that heat does not instantly travel downward. It moves slowly, over weeks. By the time it reaches 6 feet below, the season is already shifting. The ground never fully absorbs the peak heat. It remains cool because it cannot respond fast enough. It becomes, in effect, a natural thermal battery, one that is constantly buffering the extremes of the environment. This principle is not new. Civilizations across history have used it in different forms. In ancient Persia, underground chambers preserved ice through desert summers. In Europe, root cellars kept food from spoiling without electricity. These were not isolated tricks. They were consistent responses to the same physical reality. The ground holds temperature better than air. The Amish did not invent this knowledge. They preserved it. When they settled in regions like Ohio and Pennsylvania, they brought with them building traditions shaped by similar climates in Europe. They built root cellars, often 10 feet deep, where temperatures remained low enough to store food year-round. They constructed springhouses over flowing groundwater, using its constant temperature to keep dairy products fresh even in the heat of summer. And in some cases, They allowed air to move through underground pathways, letting the earth itself condition the air before it entered their homes. These systems were not designed as innovations. They were solutions, practical, reliable, and aligned with the environment. They did not require electricity or external systems. They worked because they respected the conditions around them, instead of trying to override them. In modern times, this idea did not disappear entirely. In parts of Europe, engineers revisited it with a more technical approach. Organizations like the Passive House Institute have monitored hundreds of installations, studying how buried air systems perform over time. Research from institutions like ETH Zurich has shown that, when designed properly, these systems can remain stable and effective for many years without significant loss of performance. At the same time, construction practices in the United States moved toward mechanical solutions. Air conditioning systems could be standardized, mass-produced, and installed quickly. They provided immediate, controllable comfort. They fit neatly into building codes and industry frameworks. Over time, they became the default, not necessarily because they were the only solution, but because they were the most convenient to scale. As a result, alternatives that required site-specific design, like earth tubes, became less common. Not because they stopped working, but because they required a different way of thinking. They depended on soil conditions, layout, and long-term planning. In a system that prioritized uniformity and speed, that variability became a barrier. And yet, when you look at real-world applications, the principle continues to prove itself. Buildings like the Cambridge Public Library have integrated earth tube systems to reduce energy consumption. Facilities like the Earth Ranger Center use buried tubes to precondition air, lowering the demand on mechanical systems. These are not experimental ideas. They are working systems, adapted to modern standards. For a homeowner, the question becomes practical. What would it take to use this approach in a typical house? The basic concept is straightforward. A trench is dug to a depth where the ground temperature is stable. A smooth-walled pipe is laid within that trench, long enough to allow meaningful heat exchange. The pipe is installed with a slight slope to allow condensation to drain, and it is surrounded by material that promotes good thermal contact with the soil. One end draws in outside air, while the other feeds into the home through a filtered entry point. A small fan can assist airflow. As air moves through the pipe, it gradually approaches the temperature of the surrounding soil. On hot days, it cools. On cold days, it warms. It does not replace every function of a conventional system, but it reduces the load. It turns extreme air into manageable air before it ever reaches the house. In more humid climates, variations of this system use a closed loop of liquid instead of direct airflow. A fluid circulates through buried pipes, absorbing the ground's temperature, and transfers that energy through a heat exchanger indoors. This reduces issues like condensation and air quality concerns, while maintaining the same underlying principle. What matters most is not the specific configuration, but the shift in perspective. The ground beneath a home is not just a foundation. It is a resource. It holds a steady temperature that can be accessed with relatively simple means. For generations, people understood this through observation. They built in ways that aligned with it because they had to. Today, that awareness can still be applied, not as a rejection of modern systems, but as a complement to them. Using the earth to stabilize temperature can reduce energy consumption, extend the life of equipment, and provide a level of resilience that purely mechanical systems cannot offer on their own. There is a story that brings this into focus. A homeowner in Tennessee, living in a standard house built decades ago, was dealing with rising energy costs. Instead of replacing his system outright, he explored ways to reduce its workload. He installed a buried loop beneath a nearby structure, circulating fluid through it and connecting it to a simple heat exchanger inside his home. Over time, the system began to handle a significant portion of his heating and cooling needs. His reliance on conventional equipment dropped. His costs followed. It was not perfect. It did not eliminate every expense, but it changed the balance. It gave him another option, another layer of control. And that is what this idea offers at its core. Not a miracle solution, but a different way of thinking about a problem that most people assume has only one answer. Because the truth is simple. The ground beneath your house has been holding a steady temperature your entire life. It has been doing it quietly, without maintenance, without electricity, without recognition. Whether you use it or not, it remains there, constant and available. The Amish did not preserve this knowledge because it was hidden. They preserved it because it worked. They built around it because it made sense. And while the world around them moved toward more complex systems, they continued to rely on something that required no invention, only understanding. For anyone looking at their home today, facing rising costs and increasing uncertainty, that understanding can be valuable. It does not require abandoning modern life. It requires seeing the environment not just as something to control, but as something to work with. Because sometimes the most effective solutions are not the ones we build from scratch, but the ones we uncover by paying closer attention to what has been there all along.